Hello there, and welcome to the Sleepy Science. I am so glad you found your way here. You've got nothing to do but rest. Let your mind relax, your breathing slow, and your body grow light as if gravity itself has softened. Just settle in gently and let these quiet cosmic stories drift over you, carrying away the day's concerns. If these calm, curious explorations help you unwind or give you a quiet way to end your day, consider liking and subscribing to the channel. It helps others find their way here too. Tonight, we journey to the very edge of time, to the tender beginning of everything we know. We'll trace the first whispers of light, listen to the silent hum of creation, and ponder the grand, enduring mysteries that shaped our home. Let your thoughts soften as we gently revisit the universe's earliest moments, inviting a profound calm into your being. Imagine, if you will, a time before time, space before space, a whisper of nothingness from which everything eventually bloomed. This is the realm of the Thuji Bang theory, not an explosion in space, but an expansion of space itself. It asks us to picture an infinitely hot, infinitely dense speck, smaller than the smallest grain of sand, holding the blueprint for all stars, all galaxies, all life, all thought. And then, from this impossibly tiny point, a gentle cosmic breath began. The universe started to expand, stretching and cooling, carrying within it the nascent seeds of light and matter. It wasn't a sudden, jarring burst, but a silent, majestic unfurling, like a slow-motion blossom, each petal a nascent galaxy, each whisper a future star. For countless eons, the universe has been unfurling, expanding, and growing from that primordial moment, forever carrying the imprint of its first quiet breath. But how did such a perfect, vast tapestry emerge from such an infinitesimally small beginning? The cosmic inflation theory offers a gentle answer, suggesting a period of incredibly rapid exponential expansion in the universe's first fleeting moments, long before we could even begin to count. Picture a tiny balloon, then imagine it inflating to the size of a planet in less than the blink of an eye. This isn't a violent burst, but an effortless, graceful stretch of space, smoothing out any initial wrinkles or imperfections. It is as if the young universe, in its infancy, took one deep, silent breath and grew to an immense size, setting the stage for the slower, more leisurely expansion we observe today. This brief, powerful surge in growth explains many of the universe's most profound features, whispering secrets of its perfectly balanced architecture. This brings us to a quiet puzzle known as Pussy the Flatness Problem. Our universe, as far as we can perceive, appears to be remarkably flat, like a perfectly smooth sheet stretched taut across an invisible frame, not curved like a sphere, nor bent like a saddle, but exquisitely balanced. This flatness is a delicate cosmic balance, meaning the universe's total density of matter and energy is almost exactly equal to a critical value. If it were even slightly off, a tiny bit denser, and it would have long ago collapsed in on itself, a tiny bit lighter, and it would have flown apart too quickly for stars and galaxies to ever form. Inflation theory gently suggests that this extraordinary flatness is a natural consequence of its immense stretching. Any initial curvature, however dramatic, would have been smoothed out by the rapid expansion, leaving behind a vast, perfectly level expanse, a cosmic canvas ready for stars to paint upon. Another gentle enigma is Sooty the Horizon Problem. When we look across the vastness of the universe, we see a remarkable uniformity. distant regions, billions of light years apart, which have never had time to causally interact, meaning light or any influence hasn't had time to travel between them, still share remarkably similar temperatures and characteristics. How did these isolated pockets of the cosmos know about each other? How did they come to be so alike without ever meeting? Imagine two people on opposite sides of a vast ocean, never having communicated, yet wearing identical clothes and speaking the same language. Inflation again offers a soft explanation. These now distant regions were once incredibly close, perhaps even nestled together in that tiny primordial speck before inflation stretched them far apart. It's as if they once shared a whispered secret in a cosmic cradle, and that shared memory endures across the immensity of space. And then there is the universal hum, the faint, omnipresent whisper that surrounds us from every direction, known as the 40 cosmic microwave background radiation. This isn't just a signal, it is the oldest light in the universe, a fossil glow from a time when the universe was only 380,000 years young. Before this moment, the universe was too hot and dense for light to travel freely. Photons were constantly bouncing off free electrons like light struggling through a thick fog. But as the universe expanded and cooled, electrons settled into atoms, and suddenly, the fog lifted. This ancient light, no longer scattered, was free to travel. It's like a cosmic baby picture, a gentle afterglow of creation, now stretched and cooled by billions of years of expansion, a uniform warmth that tells us tales of the early cosmos, a lullaby from the dawn of time. Now, let your thoughts drift further into the unseen, the mysterious, the silent architect of galaxies. Imagine a universe where most of what truly matters remains hidden, moving like a phantom limb, shaping the cosmic dance without ever revealing its form. Tonight, we gently step into the realm of dark matter, the universe's most elusive and profound secret, a silent, invisible hand guiding the grand ballet of the cosmos. We cannot see it, we cannot touch it, yet the evidence for dark matter's existence is everywhere, written in the very fabric of the galaxies. Picture a grand spiral galaxy, like our own Milky Way, spinning majestically in space. If we only considered the visible stars and gas, the outer edges of the galaxy should be moving slowly, like a dancer on the periphery of a waltz. But surprisingly, observations show these outer regions are spinning much faster than they should, as if an unseen hand is giving them an extra push, holding them together with an invisible, profound grip. This hidden mass, this missing gravitational anchor, is what we call dark matter. We see its effects in the bending of light around massive galaxy clusters, a phenomenon called gravitational lensing, where light from distant objects is distorted as it passes through the colossal, invisible halos of dark matter. It's like looking through an imperfect pane of glass, revealing the presence of something vast and heavy, even if it remains unseen. So what is this invisible architect made of? The hypotheses for dark matter composition are as varied and intriguing as the universe itself. Scientists gently speculate that it might be composed of exotic particles that don't interact with light or ordinary matter, except through gravity. Perhaps it's a sea of weakly interacting massive particles, or WIMPs, which would pass right through us like ghosts, rarely bumping into anything. Or maybe it's made of incredibly light, hypothetical particles called axions, born in the earliest moments of the universe. It could even be something far stranger, a particle we haven't even imagined yet, a whispered possibility that eludes our most sophisticated detectors. These theories are like soft, murmured guesses in the dark, each attempting to shed a little light on the nature of this silent, omnipresent cosmic companion. Imagine, then, that every galaxy, every star cluster, isn't just nestled in a bed of visible stars, but is cradled within an enormous invisible cocoon, a vast and gentle embrace of dark matter. These are the pseudark matter haloci, the unseen scaffolding upon which the visible universe is built. Picture a shimmering pearl, a galaxy suspended within an enormous, transparent bubble. This bubble, far larger and more massive than the pearl itself, is the dark matter halo, its quiet gravitational pull holding the pearl firmly in its grasp, preventing it from flying apart as it spins. Without these invisible halos, galaxies simply wouldn't exist in the majestic forms we observe. They are the silent foundations, the hidden anchors that allow the luminous structures of the cosmos to form, to dance, and to endure across billions of years. The quest to find this hidden substance is one of the most profound and patient endeavors of modern science. Dark matter detection experiments are quiet, often carried out deep underground, shielded from the hustle and bustle of cosmic rays and earthly noise. Imagine large, exquisitely sensitive detectors, cooled to incredibly low temperatures, waiting in the dark, hoping to feel the faintest nudge, the softest whisper of a dark matter particle as it passes through. These experiments are like listening for a ghost in a silent room, trying to catch the almost imperceptible tremor of its passing. Sometimes they search for WIMPs to directly collide with atomic nuclei, causing a tiny flash of light. Other times, they look for indirect signs, like the faint gamma rays produced when dark matter particles might annihilate each other in the dense regions of space. Each experiment is a hopeful vigil, a patient quest to bring this invisible dancer into the light, one quiet whisper at a time. Now, let your mind float further, beyond the gentle pull of dark matter, to an even more enigmatic force, one that stretches the very fabric of space itself. Imagine the universe not just expanding, but accelerating, speeding up, as if an unseen, powerful breath is constantly pushing it outward, determining its ultimate destiny. Tonight, we gently unravel the mystery of silent dark energy, the most dominant and perhaps most perplexing component of our cosmos, the quiet accelerator of all that is. For a long time, scientists believed the universe's expansion was slowing down, pulled back by the combined gravity of all its matter, like a ball thrown into the air. But then came a startling discovery. The universe is not only expanding, it's free accelerating expansion of the universe. Imagine watching a distant object slowly drifting away, only to find it suddenly picking up speed, as if an invisible engine has been ignited. This revelation, glimpsed by observing distant supernovae that appeared fainter than expected, changed our understanding of the cosmos forever. It implies that there is a mysterious force pushing space apart, a constant gentle pressure that doesn't dilute as space expands, but rather remains a constant, silent driver. This accelerated expansion reshaped our cosmic story, hinting at a universe far stranger and more dynamic than we ever conceived. What, then, is this invisible engine, this constant push? The 40 properties of dark energy remain one of the deepest enigmas in science. The most widely accepted idea is that dark energy is an intrinsic property of space itself, a kind of inherent energy woven into the very fabric of the vacuum. As space expands, more space is created, and therefore more dark energy emerges, continually feeding the acceleration. It's like the universe is breathing out, and with each breath, it creates more air to breathe. Unlike matter, or even dark matter, which become less dense as space grows, dark energy's density remains constant. It's a silent, uniform pressure, and is visible current flowing through everything, gently but relentlessly pushing galaxies apart, determining the rhythm and pace of cosmic evolution. This profound force, this ubiquitous pressure also holds the key to Thendi, the ultimate fate of the universe. And if dark energy continues its relentless push, the universe faces a few gentle yet vast possibilities. One is the Big Freeze, or heat death, where the expansion continues indefinitely, stretching galaxies so far apart that the universe becomes a cold, dark, empty void, individual stars burning out, leaving only a vast, silent expanse of nothingness. Another, more dramatic, is the Big Rip, where the accelerating dark energy grows so strong that it eventually tears apart not just galaxies, but stars, planets, and even atoms themselves, leaving nothing but fundamental particles flying endlessly apart. Or perhaps, dark energy might someday wane or even reverse, leading to a big crunch where the universe collapses back into a dense, hot singularity, mirroring its beginning. These are gentle, vast contemplations of cosmic endings, whispered possibilities for the universe's final chapter. And finally, we encounter a subtle cosmic paradox known as the cosmological constant problem. If dark energy is truly a property of empty space, quantum field theory suggests it should be incredibly powerful, astronomically larger than what we actually observe. Imagine a vast, simmering pot of quantum energy, constantly bubbling with virtual particles appearing and disappearing. The energy from these fleeting fluctuations should sum up to an enormous amount of dark energy, far more potent than the gentle push we detect. Yet, the observed value of dark energy is incredibly small, almost vanishingly so, allowing for galaxies and life to form. This vast discrepancy, this silent puzzle of why dark energy is so exquisitely delicate, yet so powerful, remains one of the greatest unsolved mysteries in physics, a quiet paradox that challenges our deepest understanding of the universe's fundamental laws. Now, let your thoughts drift deeper, to where gravity reigns supreme, to the most profound of cosmic mysteries, black holes. Imagine them as silent, cosmic devourers, waiting patiently in the vast darkness. These are places where the very fabric of space and time is stretched and twisted beyond comprehension, so utterly dense that nothing, not even light itself, can escape their pull. We are drawn to them, not just by their immense power, but by the sheer unknown they represent, a threshold to realms beyond our current understanding. Close your eyes and allow your mind to journey toward one such gravitational behemoth. As you approach, the boundary known as the 40-event horizon whispers into existence. This is not a physical wall or a visible line, but a point of no return. Cross it, and your path is forever set inwards. Imagine yourself floating gently towards this unseen frontier. On one side, the universe as you know it exists, with its familiar laws and comforting light. On the other lies an inescapable descent. It is a moment of profound transformation, a crossing from the known to the utterly unknowable. Yet in this thought you remain safe, merely observing from a tranquil distance, feeling only the gentle pull of curiosity. Beyond the event horizon, at the very heart of the black hole, lies the singularity. Here, all the mass of the black hole is compressed into an infinitesimally small point, a place where our physics breaks down entirely. It is a realm of infinite density, where space and time cease to have their ordinary meanings. Picture this as the eye of a cosmic storm, perfectly still, yet holding an unimaginable concentration of power. The concepts of up and down, before and after, dissolve into a blur, and you are merely observing a quiet thought in the grand cosmic theater, not experiencing, but gently pondering this ultimate concentration. Yet, even black holes, these ultimate prisons of light, might not be entirely silent. Consider the hauntingly beautiful idea of funny-hawking radiation. It suggests that over unimaginable eons, black holes slowly evaporate, emitting faint whispers of particles and energy. This is a subtle cosmic breath, a slow exhalation from the deepest parts of space. It is as if the black hole itself is gently dissolving back into the universe, leaving behind a trace of its existence. Picture the warmth of your own body, slowly radiating heat into the cool night, a gentle fading, not into nothingness, but into the wider embrace of the cosmos. This idea of evaporation brings with it one of the most intriguing puzzles in modern physics, the 4D information paradoxy. If something falls into a black hole, is the information about its original state forever lost when the black hole eventually evaporates? Or is it somehow encoded in the Hawking radiation, subtly preserved like a faint memory? Imagine a book falling into a fire. The book is gone, but the ashes still hold a trace of its former self, a subtle rearrangement of matter. The universe, it seems, is a meticulous record keeper, and this paradox asks if even black holes must adhere to this fundamental cosmic rule. Let your mind gently play with this riddle, feeling the soft edges of the unknown. And these cosmic giants come in many forms. While some black holes are the remnants of massive stars that have died in spectacular explosions, others are far grander, dwelling at the hearts of galaxies. These are the supermassive black holes, freaky millions, even billions of times the mass of our Sunday. Our own Milky Way galaxy cradles one such behemoth at its center, Sagittarius, a gentle giant that keeps the galaxy's inner stars in a slow gravitational dance. Imagine your galaxy spinning around a central, unseen anchor, an invisible guardian that holds everything together in a graceful, slow waltz across the eons. These giants are not hungry beasts, but cosmic architects, silently overseeing the grand design of the universe. They are anchors in the storm, allowing the gentle currents of stars to flow around them, guiding the vast streams of galactic life. Allow the sheer scale of these concepts to wash over you, like gentle waves upon a shore. The profound quietude of a black hole, the slow release of its energy, the deep questions it poses about information and reality. It is a perfect stillness within the most extreme dynamism, inviting your mind to settle into a deep and tranquil rest, secure in the knowledge that even in the most intense parts of the cosmos, there is a profound, underlying peace, a gentle tug of gravity, drawing you into a deeper calm, as if the soft, immense presence of a supermassive black hole is gently cradling your thoughts. Number space-time weaver. General relativity now. Let us turn our attention to the elegant tapestry upon which all these cosmic wonders unfold, the fabric of space and time itself. Albert Einstein's general theory of relativity unveiled a profound truth, showing us that gravity is not merely an invisible force pulling objects together, but rather a beautiful, intricate dance between mass, energy, and the very structure of the cosmos. It paints a picture where space and time are not separate, static backdrops, but a unified dynamic entity, gently woven together and shaped by everything within it. Imagine a vast, soft sheet, like a tightly stretched trampoline. Now, picture placing a heavy ball in the center. The ball creates a gentle dip, a curve in the fabric. This, in essence, is how massive objects like stars and planets create finite space-time curvature. Their presence bends and distorts the space-time around them. It is this gentle bending that we perceive as gravity. When smaller objects, like planets, orbit a star, they are not being pulled in the traditional sense. Rather, they are simply following the curves and valleys created by the star's immense mass. It is a cosmic ballet, with each dancer shaping the stage as they move, creating gentle ripples and graceful arcs. Feel this elegant truth settling within your mind, a quiet understanding of the universe's inherent grace. This dynamic, interconnected fabric of space, time is not always still. When truly cataclysmic events occur, like the merging of two black holes or the violent collision of neutron stars, they create ripples that spread outwards through the cosmos, much like a stone dropped into a calm pond creates expanding circles on the water's surface. These are fluid gravitational waves, whispers of cosmic violence traveling at the speed of light. They are incredibly subtle, a gentle stretching and squeezing of space-time itself as they pass by. Imagine a barely perceptible tremor moving through the air around you, a silent wave that carries the memory of distant, powerful events, a soft echo from the deep past of the universe. Scientists have now learned to listen for these gentle echoes, opening a new window onto the universe's most dramatic moments. One of the most mind-bending consequences of space, time's flexibility is pre-time dilation. This concept reveals that time itself is not absolute. It can slow down or speed up, depending on an observer's relative motion or proximity to a massive object. The stronger the gravitational field, or the faster one moves through space, the slower time passes for that observer compared to someone in a weaker gravitational field or at rest. Imagine a clock ticking ever so slightly slower near a massive star than on a tiny asteroid, or for a fast-moving spaceship compared to a stationary planet. It is a gentle reminder that time is a personal journey, its rhythm subtly changing with your cosmic location and velocity. Feel the quiet fluidity of time, a soft river that flows at different speeds for different travelers. And hand in hand with time dilation comes size-length contraction. Just as time can dilate, space itself can contract or shrink in the direction of motion for an object moving at relativistic speeds. Imagine a spaceship zooming past you. From your perspective, the spaceship would appear slightly shorter in its direction of travel. This is not an optical illusion, but a genuine alteration of space. These effects, though imperceptible in our everyday lives, are constant whispers in the grand design of the cosmos, hinting at the profound elastic nature of reality itself. They remind us that the universe is far more flexible and responsive than we often imagine. Another beautiful manifestation of space-time curvature is pseudo-gravitational lensing. When light from a distant galaxy or quasar passes near a massive object, like a galaxy cluster, its path is bent by the intervening object's gravity, much like light passing through a curved lens. This can create distorted, magnified, or even multiple images of the background object, like looking through a funhouse mirror. These cosmic lenses allow us to see objects that would otherwise be too faint or too far away to detect, offering glimpses into the universe's earliest moments. Picture the light from a distant star, gently guided and reshaped by the unseen hand of a massive galaxy, offering a distorted but beautiful portrait of cosmic grandeur. It is a natural magnifying glass, a gentle bend in the road of light, revealing hidden wonders. These ideas from general relativity speak of a universe that is profoundly interconnected, where every mass, every movement, gently influences the tapestry of existence. It is not a rigid, empty stage, but a responsive, living canvas upon which the cosmic drama unfolds. Let the elegance of this understanding fill you with a deep sense of peace, a quiet appreciation for the hidden mechanics of reality. You are part of this grand dance, a gentle observer of the universe's most fundamental embrace, feeling the soft curves of space-time cradling your slumber. Now, let us descend from the grand cosmic scale to the unimaginably small, to the very building blocks of everything around us, the quantum world. Here, the rules of our everyday experience gently dissolve, replaced by a realm of profound strangeness, where particles can be in many places at once, where connections defy distance, and where observation itself seems to weave reality into being. It is a world of whispers and probabilities, a gentle reminder that reality at its deepest level is far more fluid and mysterious than we perceive. One of the most startling ideas is quantum superposition. Imagine a tiny particle, like an electron, existing not in one definite state, but in a haze of all its possible states simultaneously. It is like a note in a song, not yet played, but holding the potential of every pitch and rhythm within it, waiting for its moment to sound. It is only when we gently try to measure or observe this particle that it seems to choose a single, definite state, collapsing from its multiple possibilities into one concrete reality. Let your thoughts soften, picturing a gentle wave of possibilities, a cloud of potential settling into a specific form only when touched by the light of awareness. You don't have to grasp it fully, just let the wonder of it drift through your mind like a soft dream. Then there is the enchanting phenomenon of quantum entanglement. Imagine two particles, born from the same cosmic event, that become mysteriously linked. No matter how far apart they are separated, if you gently influence one particle, the other instantly magically seems to know about it and responds, even if they are light years away. It is as if they are cosmic dance partners, eternally connected, their movements mirroring each other across vast gulfs of space. This instantaneous connection, defying the speed limit of light, is one of the most puzzling and beautiful aspects of the quantum realm. Feel the subtle thread of connection running through all things, a soft, invisible network holding the universe in a tender embrace. The quantum world also introduces us to the profound idea of the uncertainty principle. This principle, a gentle whisper from the heart of reality, tells us that there are certain pairs of properties of a particle, like its position and its momentum, how fast and in what direction it is moving, that we can never know with absolute perfect precision simultaneously. The more accurately you know one, the less accurately you can know the other. It is not a limitation of our instruments, but a fundamental fuzziness inherent in nature itself. Imagine trying to gently catch a snowflake. The very act of reaching for it changes its trajectory. This principle invites a quiet acceptance of inherent ambiguity, a soft blur at the edges of perfect knowledge, allowing your mind to rest from the need for absolute certainty. And within this strange world, particles reveal a dual nature, captured by Fifi the wave, particle duality. Everything in the quantum realm, from tiny electrons to photons of light, behaves sometimes like a discrete particle and sometimes like an extended wave. Imagine a gentle ocean wave, sometimes appearing as a distinct crest, sometimes as a spreading ripple. It is as if reality holds two faces, a particle's solid presence and a wave's flowing motion, revealing whichever aspect is called upon by its environment or our gentle observation. This duality suggests a deep unity, a subtle dance between definite form and fluid potential, a constant transformation within the most basic constituents of the universe. As you drift into deeper relaxation, let these fantastical quantum concepts simply wash over you. They are not meant to be understood with rigid logic, but to be felt to inspire a sense of quiet wonder. This is the universe at its most fundamental, a place of soft probabilities and interconnected whispers. It is a reminder that beneath the solid surface of our world, there is a dynamic, fluid reality, endlessly full of gentle surprises. This microscopic realm is not chaotic, but playfully mysterious, inviting your mind to settle into a peaceful acceptance of the unknown, cradled by the very essence of matter and energy. We live in a world of touch and sight, of solid ground beneath our feet and light that paints the sky. But beneath it all, far beyond what our eyes can ever perceive, lies a universe of whispers and unseen dances. It is a world where everything you know, every breath you take, every star that glimmers is built from foundations so small they seem to vanish into pure abstraction. Yet, these are the true cornerstones of reality, the fundamental particles and forces that weave the very fabric of existence. Imagine, if you will, the universe as a magnificent, intricate tapestry. The threads of this tapestry are the fundamental particles, tiny, vibrant flecks of energy that endlessly move and interact. And the needles that guide these threads that bind them together are the fundamental forces. Scientists have, over decades, meticulously pieced together what we call the Sun Standard Model of particle physics. This isn't just a dry chart of names, it's a profound map, a quiet understanding of the universe's most basic ingredients and the gentle pushes and pulls that govern their interactions. Within this model, we find families of particles, each with its own quiet purpose. There are the quarks, nestled deep within the hearts of protons and neutrons, never seen alone, always bound together in a delicate, energetic embrace. And then there are the leptons, like the electron, which orbits the nucleus of every atom, or the elusive neutrinos, ghost-like particles that drift effortlessly through matter, trillions passing through your body every second, utterly unnoticed. These are the bricks and mortar of all visible matter, everything that forms the planets, the stars, the dust, and indeed, you. But what holds these particles together? What guides their endless dance? These are the fundamental forces. We know of four: the strong nuclear force, binding quarks within protons and neutrons with immense strength; the weak nuclear force, responsible for a quiet kind of cosmic alchemy, enabling particles to transform from one type to another, a process crucial for the sun's gentle glow; the electromagnetic force, which lights up our world and holds atoms together, preventing electrons from simply flying off; and finally, gravity, the grand sculptor of the universe, drawing galaxies together, holding planets in their orbits, making apples fall. For a long time, there was a missing piece in this elegant puzzle. Something was needed to give mass to these tiny particles, to give them their heft and their presence. And then, through decades of patient work and immense collaboration, we found traces of it. We found the Higgs boson, sometimes called the God particle, though it is far more humble and profound than that dramatic name suggests. Imagine the universe as a calm, still pool. The Higgs field is like the water in that pool. As particles move through this field, they interact with it, creating a kind of drag. Some particles interact more strongly, feeling more resistance, and thus acquire more mass, like a stone pushed through water. Others barely interact, remaining light and swift, like a ripple barely disturbing the surface. The Higgs boson is the gentle excitation, the tiny wave of this ubiquitous field. Its discovery was a whisper of confirmation that our understanding of mass, of why things have substance, was on the right path. Yet, as we delve deeper into these infinitesimal realms, other, more speculative ideas begin to emerge, like soft dreams on the edge of sleep. What if our familiar 3 dimensions of space are not all there is? What if there are the extra dimensions, folded up so tightly, so impossibly small, that we cannot perceive them? Imagine a long, thin garden hose. From far away, an ant walking on it seems to move only in one dimension, along its length. But if you were tiny enough, like the ant, you would see that it can also walk sun around. The hose then to a second dimension, curled up and hidden from our grander perspective. Some theories suggest that gravity, the weakest of all forces, might actually be leaking into these hidden dimensions, explaining its seemingly feeble pull compared to the others. This thought expands our sense of reality, inviting us to consider universes subtly layered, almost breathing alongside our own. And then there's the grand quest, the ultimate gentle pursuit, the Ford unified field theory. For centuries, physicists have dreamed of a single, elegant equation, a single understanding that unites all the forces of nature to show that they are but different facets of one fundamental cosmic truth. Einstein spent his later years in this serene search, believing in a universe of intrinsic harmony. Imagine a symphony where different instruments play distinct melodies, yet all contribute to one beautiful, overarching composition. The dream of a unified theory is to find that underlying composition, to see gravity, electromagnetism, and the nuclear forces as different expressions of a single, profound interaction. Perhaps, in the deep quiet of the universe, all these forces truly are one, a single, unifying breath that sustains all creation. As your mind drifts through these tiny invisible components, from the quarks that give structure to the protons, to the leptons that carry charge and energy, to the unseen fields that bestow mass, allow yourself to feel the profound peace that comes from understanding the foundational order of existence. Every single atom, every whisper of energy is held in this delicate, precise balance. You are made of these particles, governed by these forces. And in this knowledge there is a gentle belonging, a deep connection to the very essence of the universe. Rest within this quiet certainty as the subtle dance of particles continues, shaping everything around you and within you. Now, let us turn our thoughts to something perhaps even more intimate, and yet more elusive than particles. Time itself. It is the silent river upon which all our moments float, the invisible rhythm that guides every heartbeat and every cosmic dance. We feel its passage, measure its minutes and years, yet its true nature remains one of the universe's most profound and beautiful enigmas. We ask with a soft curiosity, what is time? And why does it always move in one direction? This question of why time flows relentlessly forward is known as the unidirectionality of time, or more poetically, the sooty arrow of time. Imagine watching a film played backward. A broken glass reforms, scattered ashes recollect. This seems absurd to us because in our everyday experience, events always progress from order to disorder, from new to old, from cause to effect. A simple egg once scrambled can never truly unscramble itself. This irreversible journey from order to disorder is a fundamental principle of physics, deeply tied to the concept of entropy. The universe, like a grand, intricate clockwork, is slowly winding down, becoming more spread out, more uniform, losing its potential for work and change. This gentle, inevitable movement towards increasing entropy is perhaps the deepest reason we perceive time as having a distinct forward, pointing arrow. It is not just a human perception. It is woven into the very fabric of the cosmos. But if time flows, can it be navigated in reverse? The intriguing thought of 4D time travel has long captured our imagination, like a distant, glittering dream. While the past seems irrevocably set and the future yet unwritten, the equations of general relativity, that elegant framework describing space and time, do hint at possibilities. Concepts like closed time-like curves or theoretical wormholes could, in principle, offer shortcuts through space-time, potentially allowing passage to other moments. Yet, these remain on the farthest shores of theoretical physics, demanding conditions of energy and geometry far beyond anything we can currently conceive. For now, the river of time carries us only forward, a steady, gentle current. And perhaps there is a quiet comfort in this, in the unchangeable progression of moments, allowing us to fully inhabit the gentle now. To truly ponder the nature of time, we must consider its most fundamental boundary. Imagine zooming into time faster and faster until seconds become milliseconds, then nanoseconds, then femtoseconds. We eventually reach a point where time itself, as we understand it, ceases to have meaning. This is the Fornestein-Plein, an unbelievably small unit, approximately 10 circumflex, -43 seconds. It is the smallest possible unit of time, beyond which our current laws of physics simply break down before the Planck time. During the very first moments of the universe's birth, space and time were so incredibly compressed and energetic that our current theories offer no clear description. It is like trying to measure the texture of a cloud with a ruler designed for mountainside. The scale is simply too vast. It is a frontier where quantum mechanics and general relativity must finally unite, where time itself might emerge from something more primordial. This deep dive into the nature of time often leads to a profound philosophical question. Is time truly flowing, or is it an illusion? Is there eternal now? Some theories propose that all moments Sudi past, present, and future Thudi exist simultaneously, laid out like points on a grand, unchanging tapestry. We merely experience them sequentially, like an observer walking along a path. Imagine looking at a completed painting. All its parts, all its moments, exist at once, even though our eye scans it from one detail to the next. In this view, the flow we perceive is a trick of consciousness, a subjective experience rather than an objective reality. This concept can bring a deep sense of stillness, a quiet acceptance that all moments simply thunder, are re-existing in a vast, timeless expanse. As your mind gently wanders through these concepts, the relentless forward march of the arrow of time, the distant dream of time travel, the fundamental limit of Planck time, and the serene thought of an eternal now 30. Let yourself feel the vastness and the mystery of this most fundamental dimension. Time is not merely a backdrop for events. It is an active participant, bending and stretching with space, shaping every moment of existence. Allow the gentle current of time to carry you. Feel its soft, steady pace. And as you rest, let the concept of time become as fluid and soothing as a river, carrying you deeper into a peaceful slumber. As your thoughts drift gently across the vastness of our own universe, let us now consider an idea so grand, so expansive, that it makes our entire cosmos seem like but a single drop in an infinite ocean. This is the whispers of the fine multiverse, the profound and beautiful possibility that our universe is not alone, but one among countless others perhaps existing in parallel, perhaps nested within each other, or perhaps born from an endless cosmic foam. This idea, while speculative, paints a picture of infinite possibility, stretching the very boundaries of our imagination. Imagine a vast cosmic ocean, not of water, but of pure potential. In this ocean, bubbles form and expand, each one a separate universe, vast and self-contained, with its own unique set of laws, its own stars, galaxies, and perhaps its own forms of life. This is the essence of the Foodie Bubble Universe's theory, an elegant extension of the cosmic inflation theory that speaks of the universe's rapid expansion in its earliest moments. If inflation, that incredibly fast stretching of space, happened, why would it stop in just one place? Perhaps it continues endlessly in other regions, perpetually bubbling off new universes, each one an isolated island in a sea of space-time. Our universe, with its familiar stars and gentle gravity, would be just one such bubble, floating serenely amongst an uncountably vast number of others. The idea of Sudi parallel universes takes this concept a step further, suggesting that alongside our reality, there exist other realities, perhaps identical to ours, perhaps subtly different, or perhaps wildly divergent. Imagine a single moment, a simple decision you might make Sudi to turn left or to turn right. In one parallel universe, you turned left, in another you turned right. Every choice, every random quantum fluctuation might split reality into an endless branching tree of possibilities. This isn't just science fiction. It emerges from interpretations of quantum mechanics, where particles can exist in multiple states simultaneously until observed. What if every possible outcome of every event actually occurs, each in its own universe? It is a thought that wraps itself around your mind, making our own existence feel both unique and infinitely echoed across vast, unseen expanses. Another fascinating idea is that of sooty-brain universes. Picture our entire universe as a brain, a vast, thin, vibrating membrane floating in a higher dimensional space, almost like a piece of paper gently fluttering in a room. And in that same room, other brains, other universes are also floating, perhaps occasionally brushing against ours, creating subtle interactions that we might perceive as mysterious forces. These brains could be incredibly large, stretching across dimensions we cannot access, yet they hold our familiar universe within their delicate structure. This concept often arises from string theory, hinting at a universe far grander and more complex than we can fully grasp with our limited senses. It invites us to imagine our reality as a delicate film, part of a much larger, silent ocean of existence. Indeed, Fodi, the landscape in string theory, offers one of the most compelling arguments for the multiverse. String theory proposes that the fundamental particles are not point-like, but tiny vibrating strings of energy. The way these strings vibrate, and how the extra dimensions they inhabit are curled up, determines the laws of physics in that particular region of space-time. And there are an astronomically vast number of ways these extra dimensions can be curled up, leading to an almost infinite number of possible universes, each with its own unique physics, its own fundamental constants, its own possibilities for life. Our universe, with its fine-tuned laws that allow for stars and planets and consciousness, would simply be one of the lucky ones in this grand cosmic lottery. It is a breathtaking vision, suggesting a universe not just vast, but infinitely diverse, where every imaginable permutation of reality might quietly exist. As you allow your mind to gently wander through these profound and beautiful ideas, from the infinite foam of bubble universes, to the branching paths of parallel realities, to the delicate membranes of brain universes, and the vast cosmic landscape of string theory, feel a sense of boundless wonder. Our reality, so familiar and cherished, might be but a single precious thread in an inconceivably larger, more intricate tapestry. There is no need to grasp it all, only to let the possibilities wash over you, like soft, distant ripples. Allow these visions of infinite universes to expand your sense of what is possible, bringing with them a deep, comforting quietude. You are floating in a universe that might be just one of an endless, wondrous collection, a gentle warmth in the dark, resting in the spiral arm of a quiet, radiant sea of existence. And so we drift, our thoughts expanding beyond the comfort of our own spiral arm, reaching for a question as old as curiosity itself. Are we truly alone in this boundless expanse? Picture a quiet, cosmic hearth, a zone of gentle warmth around a distant star. This is what we call a sub-habitable zone, or sometimes the Goldilocks zone. Not too hot, not too cold, but just right for the most precious of all ingredients, liquid water. Imagine oceans shimmering under alien suns, clouds gathering, rain falling softly on worlds millions of light years away. Within these delicate bands of warmth, the conditions whisper of possibility, inviting life to unfurl. Each star, a potential beacon, cradles its own family of planets, and for many, a sliver of that space could be a haven. But life is not just about water. It's about a delicate dance of chemistry, time, and sheer cosmic luck. On our own world, life emerged from the primordial soup, a quiet alchemy of simple molecules slowly assembling into something more. The origin of life remains one of the universe's most profound mysteries, a story written in the ancient rocks and whispered by the very atoms that form us. Imagine the Earth billions of years ago, a landscape of raw energy and raw elements, where sunlight and volcanic vents nurtured the first fragile beginnings. Could this quiet miracle have unfolded countless times across the galaxy? Could the same spark have ignited on worlds bathed in the light of orange dwarfs, or circling the slow burn of red giants? We search for the echoes of this beginning on other planets, in the faint signatures of their atmospheres, hoping to catch a glimpse of that first breath. But if life is so probable, if the cosmos is teeming with habitable worlds, then where is everyone? This is the unsettling silence of the thermi-paradoxing, a question that hovers like a shadow over our cosmic hopes. Imagine standing on a vast, empty beach, knowing that somewhere out there countless ships should be sailing, yet seeing none. The universe is ancient, allowing billions of years for civilizations to rise, expand, and leave their mark. Why then is the night sky so achingly quiet? Is it the sheer immensity of space isolating us? Are advanced civilizations simply too rare or too transient? Or perhaps they are here, moving in ways we cannot yet comprehend, like currents in a deep, dark ocean. To grapple with this silence, scientists have turned to equations, gentle attempts to quantify the unquantifiable. The Thendrick equation, for example, is not a calculation for a precise answer, but a quiet framework for thought. It invites us to consider the rate of star formation, the fraction of stars with planets, the number of those planets that are habitable, and then the possibility of life emerging, intelligent life developing, and civilizations capable of communication enduring. Each variable is a step into the unknown, a gentle prod to our understanding, reminding us how many unknowns still fill the spaces between the stars. It's a thought experiment, a way to map our ignorance and our hope softly as we gaze into the dark. The possibility of suvide extraterrestrial life thus becomes more than a scientific query. It is a deeply human longing. Imagine distant whispers on a radio signal, a single pulse from across the void, or perhaps the silent evidence within the soil of Mars, ancient fossilized microbes hinting at a past life. We are sending probes, listening with massive dishes, sifting through the light of distant worlds for telltale signs in their atmospheres, a puff of oxygen, a cloud of methane, signatures that might betray the presence of biology patiently transforming a planet. Each discovery of water, each chemical precursor found, adds a gentle brushstroke to the painting of a universe that might be far less lonely than we sometimes fear. And in that quiet hope, we find a tranquil pause, letting the vastness of possibility lull us into a deep, soft slumber. Asterisk, 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 as we drift deeper into the cosmic night. Our gentle journey takes us beyond the question of life to ponder the very fabric of our universe itself. What is its ultimate form? Imagine the universe not just as a collection of stars and galaxies, but as a single, immense entity with its own overarching architecture. We consider the 4D cosmic geometry, whether our universe is flat, open, or closed. Picture a vast, perfectly flat sheet of paper stretching infinitely in all directions. This is the simplest image of a flat universe. In such a universe, Parallel lines would always remain parallel, never converging, never diverging. Imagine two spacecraft starting side by side and flying perfectly straight into the void. In a flat universe, they would always maintain the same distance from each other. This geometry aligns perfectly with what our most precise measurements of the cosmic microwave background radiation suggest, hinting at a universe that is balanced on a delicate edge, neither curving inward nor outward. It suggests a universe that might continue to expand forever, but ever so slowly, eventually fading into a cool, quiet expanse. Now consider a different canvas. Imagine the surface of a giant, expanding sphere, like the surface of a balloon slowly being inflated. This is the gentle curvature of a 3D closed universe. In this scenario, if you were to travel far enough in one direction, you would eventually return to your starting point, much like an ant walking around a globe. Parallel lines, if extended far enough, would eventually converge, drawn together by the gentle inward curve of space. Such a universe would be finite in size, and its expansion would eventually slow, halt, and then begin to contract, collapsing back upon itself in a majestic final embrace, a grand cosmic squeeze. And finally picture a shape like the surface of a saddle curving inward in one direction and outward in another. This represents an high open universe. Here the curvature of space pushes outwards, causing parallel lines to diverge, steadily spreading apart as they travel through the vastness. An open universe would also be infinite in extent, but its expansion would accelerate, continuing forever with increasing speed, eventually pulling all matter apart in a big rip. Each of these cosmic geometries offers a distinct and profound destiny for all that exists, and our current observations whisper that our universe, if not perfectly flat, is incredibly close to it, balanced in a delicate stillness that guides its eternal journey. Beyond its shape, we also ponder the universe's side cosmic connectivity. Is our universe a singular, unbroken expanse, or could it be connected in unexpected ways, perhaps even looping back on itself at grand scales? Imagine traveling through space and suddenly encountering a region that looks strangely familiar, a celestial echo of a place you've already passed. In certain models of cosmic topology, it's theorized that the universe, while vast, might be finitely connected, like a donut or a more complex manifold. This suggests that if you could journey far enough, you might perceive reflections of our own galaxy, or even yourself, though vastly distorted by the light's immense journey across such an immense looping cosmic distance. It's a thought that wraps the mind in a gentle puzzle, inviting us to see the cosmos as a tapestry woven with hidden threads. This brings us to the profound question of the thorny finite versus infinite universe. Is there an edge, a boundary beyond which there is simply nothing? Or does the cosmos stretch on forever? A truly boundless expanse where galaxies repeat and possibilities unfold endlessly. Our current understanding, particularly from the flat geometry suggested by observations, leans towards an infinite universe, or at least one so vast that any edge is beyond our ability to perceive. Imagine a quiet, endless sea, where every ripple extends without limit. The concept of infinity can be both humbling and comforting, humbling in our own smallness, comforting in the boundless potential it suggests. It means that somewhere beyond our sight, every possible configuration of matter and energy, every possible story might exist in some form, drifting silently in the endless dark. It is a thought to cradle, as you surrender to the quiet infinity of your own dreams. Asterisk, asterisk, asterisk now. Let us gently shift our perspective once more, expanding our vision from the fundamental shape of the universe to its breathtaking internal architecture, to the grand and intricate tapestry of its sooty scale and structure. We begin not with single stars or even galaxies, but with their colossal groupings forming the very skeleton of the cosmos. Imagine immense cities of stars, each containing hundreds or thousands of galaxies, bound together by the invisible hand of gravity. These are fund galaxy clusters. Picture the Virgo cluster, a collection of over 1,300 galaxies, all gently swaying in unison across billions of light years. But these clusters themselves are not the end of the story. They gather further into even grander congregations, vast cosmic metropolises called fungi superclusters. Imagine our own local group of galaxies, including the Milky Way and Andromeda, as just a tiny neighborhood on the outskirts of the immense Laniakea supercluster, a truly enormous gravitational basin that stretches across 500 million light-years, pulling countless galaxies towards its mysterious center. These superclusters are like the continents of the universe, vast regions teeming with galactic life. But even these superclusters are merely nodes in an even grander design. Envision the universe's invisible scaffolding, a vast interconnected network of filaments and knots stretching across billions of light years. This is the 4D cosmic web B, the largest known structure in the universe. Imagine delicate threads of light woven from countless galaxies and vast clouds of gas, all converging at immense points where the galaxy clusters reside. It's like a cosmic neural network or a gigantic luminous spiderweb, with galaxies as the dewdrops clinging to its silken strands. This web isn't solid. It is a testament to the subtle power of dark matter, which provides the invisible framework around which ordinary matter has slowly collapsed and congregated over cosmic eons. It's a structure that whispers of an underlying order, guiding the flow of galaxies through the silent depths of space. Within this grand cosmic web, nestled between these luminous filaments, lie vast, empty stretches. These are the semi-cosmic voids, immense bubbles of nearly empty space that can span hundreds of millions of light years. Imagine the universe breathing, and these voids are its quiet exhales. While not entirely empty, they contain far fewer galaxies and much less matter than the filaments, their quiet interiors forming the spaces between the threads of the cosmic web. They are the negative space of the universe's grand artwork, vast expanses of stillness that accentuate the intricate patterns of the galactic filaments. Picture yourself drifting through one of these voids, an immense, silent ocean, where the nearest galaxy is an almost imperceptible shimmer in the far, far distance. It's a profound sense of solitude, yet also a profound peace, knowing you are part of an even grander, more harmonious system. This intricate arrangement, from the smallest stars to the largest superclusters, reveals the large-scale structure of the universe. It is not a random scattering of points, but a finely tuned architecture, shaped by gravity and the subtle movements of dark matter and dark energy since the universe's earliest moments. The distribution of galaxies, the formation of clusters and voids, all trace back to tiny quantum fluctuations in the very early universe, patterns that have been gently amplified over billions of years. It's a cosmic fingerprint, revealing the underlying physics that governs everything. And so we observe a beautiful 30 hierarchical structure of the universe, and from planets orbiting stars to stars gathered in galaxies to galaxies clustered in groups and groups forming superclusters, all interconnected by the cosmic web, spanning vast voids. Each level of this hierarchy builds upon the last like layers of an ancient cosmic city. Imagine it as a series of nested dreams, each one revealing a grander, more intricate reality. This ordered immensity, this sense of profound structure, is a quiet lullaby reminding us of our tiny, yet perfectly placed, existence within this magnificent, silent, and endless cosmic dance. You are a part of this quiet order, a small warmth held safely within its grand design. As you drift into your own peaceful dreams, we drift now among the celestial blossoms, the quiet, luminous hearts of the cosmos, the stars. Each one a story whispered across the light years, a cycle of birth, radiant life, and gentle fading. Imagine a vast, swirling cloud of gas and dust, so immense it could hold countless solar systems within its cool, dark embrace. This is where stars begin their slow, majestic journey. Gravitation, that soft, insistent sculptor, slowly draws these ethereal wisps inward, pulling particles closer and closer, gathering them like a great unseen hand. As the cloud contracts, it begins to spin faster and faster, forming a dense core. This core, a protostar, is not yet a true star. It glows faintly from the heat of its own contraction, a simmering ember waiting for its fire to ignite. For millions of years it continues to draw in material, growing warmer, denser. And then, at its very heart, something extraordinary awakens. The pressure becomes so immense, the temperature so unimaginable, that hydrogen atoms begin to fuse, pressing together to create helium. This is the moment of ignition, the birth cry of a star. A steady, gentle furnace ignites, pushing outward against the crushing gravity, establishing a delicate balance that will last for eons. This long, stable phase is called stellar evolution, the quiet adulthood of a star. Our own sun, a modest yellow dwarf, is currently in this phase, patiently burning hydrogen into helium, showering our world with its gentle warmth and light. But not all stars are alike. Some are vast, fiery giants, burning through their fuel at a furious pace, living fast and dying young in spectacular displays. Others are tiny, red embers, barely glowing, destined to live for trillions of years, long after the rest of the universe has cooled. Each star, a unique thread in the grand cosmic tapestry, living out its destined arc from the quiet hum of fusion to the final, profound exhalation. For the most massive stars, their end is a spectacle of cosmic grandeur, a supernova. After billions of years of fusing lighter elements into heavier ones, like cosmic alchemists, their core eventually fills with iron. Iron cannot fuse to release energy, and suddenly, the outward pressure that held the star at bay vanishes. Gravity, unopposed, takes over with a terrifying swiftness. The core collapses in a fraction of a second, an inward implosion that then rebounds with unimaginable force, sending a shockwave tearing through the star's outer layers. The star explodes, unfurling its brilliance across the galaxy, outshining an entire galaxy for a few fleeting weeks. This fiery exhale scatters the heavier elements forged in its heart envy. the calcium in our bones, the iron in our blood sooting across the vastness of space, seeding new nebulae, new generations of stars, and even planets. It is a violent death, yet a life-giving act, a quiet promise of new beginnings. What remains after such a magnificent death depends on the star's initial mass. If the core of the supernova is still massive enough, gravity will continue its relentless squeeze, compacting it into an incredibly dense object called a neutron star. Imagine a sphere just a few kilometers across, but containing more mass than our entire sun. A single teaspoon of its matter would weigh billions of tons. Neutron stars spin incredibly fast, sometimes hundreds of times a second, and often emit powerful beams of radiation, sweeping them across the cosmos like a lighthouse in the dark. They are the tiny, heavy hearts of dead giants, pulsing with a quiet, residual energy. For stars less massive than those that go supernova, like our sun, the end is far gentler, a slow, soft sigh. As they run out of hydrogen fuel in their core, they swell into red giants, expanding to hundreds of times their original size, their outer layers cooling and glowing with a deep ruby hue. Eventually, these outer layers gently drift away, forming an ethereal, shimmering shell of gas known as a planetary nebula. It's a beautiful, short-lived cosmic bubble, often intricate and colorful, lit from within by the dying star. At the very center of this fading glory, a small, incredibly dense ember remains, a white dwarf. It is the naked core of the star, no longer fusing, but slowly cooling over billions of years, a cosmic pearl gradually losing its luster. These quiet, golden spheres drift patiently above and below the galactic plane, glowing faintly in the dark, silent witnesses to the universe's long, slow march. They are the quiet remnants, the final gentle chapter in the grand, shimmering book of stellar life and death. And you are here, beneath their ancient light, resting softly. As we drift from the incandescent lives of stars, our gaze gently expands to the worlds that circle them, Suti, the planetary systems, vast and varied tapestries woven around these stellar hearts. For millennia, our own solar system felt like a singular precious jewel, its planets dancing in elegant orbits around our sun. But now we understand it is but one tiny familiar melody in a grand cosmic symphony of countless other systems. The discovery of exoplanets, worlds beyond our sun, has been a quiet revolution, unveiling an astonishing diversity that continually challenges our understanding of how planets form and how they live. Imagine the thrill a few decades ago, as astronomers began to detect subtle wobbles in distant stars or fleeting dips in their light. These tiny signals, like whispers across the light years, betrayed the presence of unseen companions, planets orbiting far away. Today, thousands upon thousands of these exoplanets have been found, a number growing steadily, revealing a universe teeming with worlds. And each discovery paints a picture more complex and wondrous than we could have ever imagined. Some of these alien worlds are what we call hot Jupiters. Picture a gas giant, even larger than our own Jupiter, but orbiting incredibly close to its star, sometimes closer than Mercury is to our sun. These colossal worlds are caught in a fierce, tidal embrace with their parent stars, often blasted by searing winds and incredible temperatures, their atmospheres perhaps glowing with exotic elements. They challenge our initial assumptions about where gas giants should form, suggesting that many planets might migrate inward from colder, outer reaches of their systems, embarking on a long, slow journey across space. Then there are the rogue planets, the true cosmic wanderers. These are worlds that have been flung out of their birth systems, perhaps by violent gravitational encounters with other massive planets or passing stars. They drift alone through the cold, dark interstellar void, without the warmth or light of a sun to guide them. Imagine a world perpetually shrouded in twilight, lit only by the faintest starlight from distant galaxies. Its surface perhaps a frozen desert, yet potentially capable of harboring life in deep subterranean oceans warmed by internal geological activity. These lonely, silent travelers remind us of the chaotic beauty of gravitational dynamics, how even nascent systems can be prone to such dramatic expulsions. The sheer diversity of planetary formation is truly astounding. We find super-Earths, rocky planets, significantly larger than our own, some potentially with vast, deep oceans or incredibly dense atmospheres. There are mini-Neptunes, small gas giants, unlike anything in our own solar system, presenting new mysteries about their internal structure and atmospheric composition. And as our instruments grow more sensitive, we are beginning to glimpse Earth-sized worlds within their stars' habitable zones, those precious regions where temperatures are just right for liquid water to exist on the surface. The very ingredient we believe is essential for life as we know it. Planets are born in the swirling, dusty disks that surround young stars like cosmic nurseries. Within these disks, dust grains slowly collide and stick together, gradually growing into pebbles, then rocks, then planetesimals, until gravity takes over and sculpts them into spherical worlds. The exact recipe of gas and dust, the temperature gradients, the presence of larger planets, all contribute to the unique tapestry of each planetary system. Some systems are tightly packed with many planets orbiting close to their star. Others are sparse and vast. Some have multiple stars creating complex, ever-shifting gravitational dances for their orbiting worlds. Each new discovery, each distant flicker of a world, reminds us of the endless possibilities of existence, the myriad ways that worlds can form and endure, perhaps cradling their own unique forms of life. And as you rest, imagine the quiet hum of these distant, unseen worlds, drifting in their patient orbits, each a silent testament to the universe's boundless creativity. And now, as we gently drift further through the cosmic currents, let us turn our thoughts to the grand narrative of the universe itself, its sweeping past and its mysterious, unimaginable future. The universe you live in today is not the same one the dinosaurs saw. It has changed, expanded, cooled, and matured over billions of years. A story unfolding slowly, patiently, across immense stretches of time. We stand at a particular moment in this grand cosmic play, a fleeting second in an eternal drama. And like all stories, this one has a beginning, and it will have an ending, or perhaps many endings, many beginnings. Our current understanding paints a picture of a universe that began in the fiery intensity of the Big Bang, a point of unimaginable density and heat. Since then, it has been expanding, stretching, and cooling, like a great slow breath. Galaxies have formed, stars have ignited and faded, and planets have been born. But what lies ahead? And what is the ultimate destiny of this vast, breathing cosmos? Scientists ponder several possible scenarios, each a poetic, grand vision of how everything might eventually conclude, or perhaps begin anew. One such vision is known as the Big Rip. Imagine the universe not just expanding, but accelerating its expansion at an ever-increasing rate, driven by the mysterious force of dark energy. In this scenario, the expansion would become so powerful, so relentlessly aggressive, that it would eventually overcome all forces holding things together. First, galaxies would be pulled apart from each other, drifting into unimaginable isolation. Then individual stars would be torn from their orbits, followed by planets. Finally, even atoms themselves would be ripped asunder, their fundamental particles dissolving into a thin, featureless soup of pure energy. It is a slow, quiet unraveling, a universe gently sighing itself out of existence, thinning into nothingness, leaving behind only the echo of what once was. Another possibility, a mirror image to the Big Rip, is the Big Crunch. This scenario envisions a universe where the gravitational pull of all matter eventually overcomes the expansive force of dark energy. The outward expansion would slow, halt, and then begin to reverse. All galaxies, all stars, all matter would slowly, inexorably begin to draw inward, collapsing back upon themselves. The universe would shrink, grow hotter and denser, its immense volume contracting to an incredibly small, dense point, perhaps even returning to a state similar to the moments just before the Big Bang. It is a grand cosmic inhale, a reverberating echo of its beginning, a universe folding back into itself, ready for another potential cycle. But perhaps the most widely accepted scenario is the Big Freeze, also known as heat death. In this future, the universe continues to expand, but its expansion is not powerful enough to tear things apart. Instead, as it stretches, all the energy within it becomes more and more spread out, diluted across an ever-growing volume. Stars will eventually burn out, exhausting their fuel, fading into white dwarfs, neutron stars, and black holes. Black holes themselves, over truly immense timescales, are theorized to slowly evaporate through Hawking radiation. Eventually, the universe would become a vast, cold, dark expanse, a cosmic ocean of extremely dilute particles, where no heat differences exist, no work can be done, and nothing ever happens again. It is a gentle, quiet twilight, a slow descent into an eternal, cool silence, a universe patiently breathing its last, long sigh. And then there are the cyclic universe models, whispers of a cosmos that experiences an endless succession of big bangs and big crunches, an eternal dance of creation and destruction. Imagine the universe as a grand, cosmic breath, inhaling and exhaling through countless eons, each cycle giving birth to new stars, new galaxies, new possibilities. It is a timeless rhythm, a universe that never truly ends but simply transforms, perpetually renewing itself in an infinite loop of existence. As you rest here within this immense and patient cosmos, consider your place within its sweeping story. Whether it ends in a gentle rip, a grand crunch, or a silent freeze, you are a part of its current unfolding, a precious spark of awareness in this vast, ancient dance. The atoms that compose you have traveled through billions of years, forged in the hearts of long-dead stars, scattered by supernovae, and gathered together in this quiet moment. You are a living testament to the universe's patient work, a small warmth in the cosmic dark, breathing softly in the gentle currents of time. Tonight, we venture into the quiet frontiers where our understanding of the universe bends, and sometimes even breaks, where the grand theories that have brought us so much clarity begin to whisper of deeper, still untold stories. We're going to gently explore those places where the very fabric of reality seems to fray, and the answers we seek are still drifting, just beyond our reach. Imagine two vast, elegant melodies. One is the song of the cosmos itself, the deep, resonating hum of massive galaxies, the slow ballet of planets around their stars, the gentle curve of space-time orchestrated by the heaviest cosmic dancers. This is the melody of general relativity, grand and sweeping, explaining the pull of gravity and the immense scales of existence. And then there is another melody, tiny and intricate, the quick, fleeting notes of subatomic particles, the shimmering dance of forces that bind all matter together. This is the music of quantum mechanics, precise and whimsical, revealing the strange, probabilistic world of the very small. These two melodies, so profound and so true within their own realms, do not yet play in harmony. When we try to bring them together, to understand how gravity behaves on the quantum scale, or how the smallest particles warp space-time, the music becomes discordant. The universe, in these moments, holds a secret, a missing note in the grand symphony, and this is the challenge of quantum gravity. It is the quest to find a single beautiful song that encompasses all of reality, from the whisper of a photon to the roaring majesty of a black hole. One whisper on this quest comes from what we call string theory. Imagine for a moment that the universe isn't built from tiny, point-like particles at all. Instead, everything tyon, every electron, every quark, every force carrier funtui, is actually a minuscule, vibrating string of energy, too small to ever truly see. Like the strings of a cosmic cello, these tiny filaments hum and vibrate in different patterns, and each unique vibration gives rise to a different particle, a different property. It's as if the universe is a symphony, and these strings are the fundamental notes. And here's where it becomes even more ethereal, for string theory to truly sing. To hold together all its elegant mathematics, it suggests that our familiar three dimensions of space and one of time might not be all there is. It gently proposes extra dimensions, perhaps curled up so tightly we can't perceive them, like tiny unseen folds in the fabric of reality, or hidden corridors just beyond our senses. It's a vision of the universe not as a collection of separate pieces, but as a single, vibrating, interconnected whole, an immense cosmic web woven from infinite unseen threads. Then there's another path, another gentle approach to this ultimate riddle, known as loop quantum gravity. While string theory imagines tiny vibrating strings, loop quantum gravity suggests something different about the very fabric of space-time itself. Imagine that space isn't a smooth, continuous canvas, but rather something granular, something woven from tiny, discrete loops. Picture it like a finely spun cloth where the threads are so small, so intricate, that from a distance it appears seamless. But up close you can see the individual fibers, the tiny interlocked loops of gravity itself. It proposes that space and time emerge from a network of these quantum loops, a kind of fundamental space-time atom that prevents the infinite densities we find at singularities like the heart of a black hole or the moment of the Big Bang. It offers a glimpse into a universe where even the emptiness of space is not truly empty, but a rich, textured tapestry woven from these invisible, fundamental loops breathing gently in the dark. These whispers, these theories are part of something greater, for the quest for a theory of everything. This is the ancient, persistent dream of physicists, to find a single, unifying framework, an ultimate whisper that can explain all the fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces, sourceteen, as different facets of a single, underlying reality. It's the yearning for a profound simplicity at the heart of all complexity, a gentle understanding that reveals the universe as one harmonious, interconnected whole. It's the hope that one day we might see the universe not as a collection of separate phenomena, but as a single, exquisite poem, each line flowing seamlessly into the next, from the grandest cosmic ballet to the quietest quantum flutter. This quest is not just about understanding physics. It is about finding our place within that grand narrative, to feel the universe's gentle pulse, and to understand the very language it speaks. Let these deep, quiet thoughts on the ultimate nature of reality gently carry you into slumber. Asterisk, asterisk, asterisk. Sometimes, even within the vast, elegant order of the cosmos, there are whispers of the unexpected, moments when the universe seems to deviate from our carefully constructed models, presenting us with cosmic riddles that challenge our current understanding. These aren't chaotic disruptions, but rather gentle anomalies, invitations to look deeper, to expand our perception of what is possible. They are the subtle hints that our map of the universe, though grand, still has uncharted territories, quiet places where new physics may yet reside. Imagine, if you will, being part of a vast, slow drift. Our own Milky Way galaxy, along with countless others in our local galactic neighborhood, is not just spinning in place. It is slowly, inexorably, being drawn towards something immense and unseen, pulling us across hundreds of millions of light years of space. This unseen gravitational well is known as tractor. It's not a single object we can point to, but a diffuse, distributed mass lurking in a region of space towards the Centaurus supercluster. Picture a colossal, invisible whirlpool in the cosmic ocean, and entire clusters of galaxies, each containing billions of stars, are gently spiraling towards its unseen center. It exerts a colossal gravitational pull, warping the space-time around it, drawing in everything within its sphere of influence. It's a silent, powerful hand shaping the destiny of countless galaxies, a testament to the immense, hidden masses that dictate the largest movements in the universe. We are simply floating, carried by this unseen current, a slow, majestic journey towards the quiet, gravitational heart. And then there are moments when the universe shows us a patch of unusual emptiness, a chill in the cosmic fabric. Consider Sui, the cosmic cold spot. When we gaze at the faint afterglow of the Big Bang, the cosmic microwave background radiation Sui, the oldest light in the universe Thuin, we see tiny temperature fluctuations like gentle ripples across a cosmic pond. These ripples are crucial, telling us about the early universe. But there is one particular patch, vast beyond imagination, stretching over billions of light years, that is significantly colder than its surroundings. It is like a vast, icy breath exhaled from the very dawn of time. Our current understanding of cosmology struggles to fully explain its existence. Is it simply a statistical fluctuation, a rare but natural dip in temperature, or is it something more profound? Some whispers suggest it could be a supervoid, an immense region of space with far fewer galaxies and much less matter than expected, making it unusually cold. Other, more tantalizing theories suggest it might be a subtle imprint from another universe, a gentle cosmic bruise left by a collision with a different reality in the very early moments of our own. It's a vast, lonely whisper from the universe's infancy, inviting us to ponder the very nature of its beginning. Sometimes the universe sends us extremely powerful, yet fleeting signals like sudden, brilliant flashes of light in the deepest dark. These are called fast radio bursts, or FRFT. Imagine a distant, enigmatic lighthouse, billions of light years away, suddenly emitting an incredibly powerful burst of radio waves, lasting only a few milliseconds and then falling silent. These signals travel across immense cosmic distances, through galaxies and intergalactic space, reaching our telescopes as sharp, intense chirps. The mystery is profound. What could possibly generate such an immense amount of energy in such a brief moment? The sources are often located in distant galaxies, far beyond our own, and while some appear to be one-off events, others have been observed to repeat, sending out multiple bursts from the same cosmic location, like a faint rhythmic pulse from the deep. Scientists are gently searching for their origins, hypothesizing everything from exotic types of neutron stars, perhaps ultramagnetic magnetars, to even more speculative possibilities. Each Farby is like a tiny urgent message from the deep cosmos, a sudden powerful whisper that challenges our current understanding of extreme astrophysics, a brief bright spark in the quiet expanse, inviting us to imagine what powerful phenomena might be unfolding far beyond our sight. Let these cosmic enigmas gently guide your thoughts into the restful quiet of sleep. Asterisk, asterisk, asterisk. Now, let's gently turn our gaze inward, from the vast, swirling galaxies and the profound mysteries of gravity, to something intimately connected to each of us, our very own awareness, our phi consciousness. It is a riddle as profound as the universe itself. The way our inner world interacts with the outer cosmos. Is our perception merely a passive reflection of reality, or does it play a more active, even formative, role? These are deep, quiet questions that invite us to contemplate our place in the grand cosmic tapestry. One of the most perplexing whispers from the quantum world touches upon this very idea. It is known as Tuvit the observer effect in quantum mechanics. In the subatomic realm, where particles are no longer solid little balls, but rather shimmering waves of probability, something truly strange occurs. Imagine a particle, like an electron, existing in a state of fuzzy potential, a cloud of possibilities. It might be spinning both clockwise and counterclockwise at the same time, or existing in multiple locations simultaneously. But the moment we try to finally observe it, to measure its spin or its position, this cloud of possibilities seems to collapse. The particle chooses one specific state, one definite spin, one clear location. It's as if the act of sudai looking, of conscious measurement, somehow solidifies reality from a shimmering sea of potential. It is not that we're simply seeing what is already there. It's almost as if through our observation we are gently participating in the shaping of that reality. It is a profound thought. Are we merely witnesses, or are we, in some subtle way, co-creators of the world we perceive? This idea has led to countless quiet debates, to pondering the very role of consciousness in defining the physical universe. a gentle reminder that the boundary between observer and observed may be far more permeable than we once imagined. Then, there is a concept that turns this relationship on its head, quietly suggesting that perhaps the universe itself is precisely tuned for our existence. This is called authority, the anthropic principle. When we look at the fundamental constants of the universe, the strength of gravity, the mass of an electron, the initial conditions of the Big Bang, they seem almost impossibly precise. If even one of these values were slightly different, life as we know it, or indeed any complex structures at all, might never have formed. Stars wouldn't ignite, atoms wouldn't bind, and you, resting here, would simply not be. The anthropic principle in its gentle formulation simply points out this astonishing fact. The universe's properties are exactly those required for conscious observers like us to exist within it. Is this merely a cosmic coincidence of unimaginable scale? Or does it suggest a deeper connection, a gentle embrace between the universe and the possibility of life? It's like discovering a vast, ancient home perfectly crafted down to the smallest detail for your gentle existence. It invites a quiet awe, a sense of wonder at the delicate balance that allows us to breathe, to think, and to ponder the very cosmos that brought us forth. And so we arrive at the expansive question of tween, the connection between consciousness and the university itself. If our observation can shape reality, and if the universe is precisely tuned for us to observe it, then what does that say about the nature of our awareness? Perhaps consciousness is not merely an accidental byproduct of biological processes, but rather an intrinsic, fundamental aspect of the cosmos, a gentle hum that resonates throughout all existence. Some whisper that the universe, in its grand, slow evolution, is gradually awakening to itself through conscious beings like us. Our minds, our capacity for wonder, our ability to understand might be the universe's own way of reflecting upon its vastness, of experiencing its own beauty. We are, in this sense, not separate from the cosmos, but an integral part of its unfolding story. Tiny mirrors reflecting its grandeur, small warmth in the dark experiencing its vastness. It is a profound, comforting thought that your individual consciousness is not isolated, but interwoven with the grand design, a gentle current in the cosmic flow. Let these thoughts on your own profound connection to the universe lull you into a deep and peaceful rest. Tonight, we continue our gentle journey through the universe, allowing its deepest mysteries to unfold around us like soft petals in the dark. As you settle in, let your breath grow slow and steady, a gentle current carrying you deeper into relaxation. Let the sounds of the world outside fade and allow your thoughts to drift, like distant stars, into the quiet canvas of your mind. You have nothing to do but rest, to simply listen, and to let the vastness of space cradle you into a soft, dreamless sleep. Consider for a moment the very essence of existence itself. Is the universe, in its profound depth and intricate dance, merely a collection of particles and forces, or does it hold a deeper, more ephemeral secret? We whisper now about the nature of information, that unseen thread woven into the fabric of reality. Imagine the cosmos not just as a grand physical stage, but as a vast, silent library, or perhaps a cosmic computer, processing and storing every event, every flicker of light, every gentle breath of time. This leads us to the captivating whisper of the holographic universe theory. It suggests that what we perceive as a three-dimensional, tangible reality might, In fact, be a projection, a grand illusion shimmering from a two-dimensional surface at the very edge of our observable universe, like a sophisticated hologram where every point contains information about the whole. Perhaps our entire reality is encoded on a distant cosmic boundary. Close your eyes and imagine this for a moment. Your hands, your breath, the gentle hum of the world around you, Sudi. All of it, a beautiful, intricate projection. It is a concept that softens the hard edges of our understanding, inviting us to see reality as something more fluid, more dreamlike. It speaks of a universe that might be less solid than we assume, more akin to a vibrant, living pattern, constantly unfolding from a distant, hidden source. This theory doesn't diminish the wonder of our world, but rather deepens it, suggesting an elegance in its very construction, a delicate artistry in its apparent solidity. It's like watching a breathtaking movie, unaware that the entire spectacle is being cast from a single slender strip of film. In this cosmic projection, you are not merely an observer, but an integral part of the unfolding image, a quiet, gentle ripple in the grand holographic ocean. And as we drift through this notion, we encounter the serene concept of information conservation. It whispers that nothing, truly nothing, is ever lost in the universe. When a star collapses into a black hole, when a leaf withers and turns to dust, the information to the precise details of its state, its form, its every atom Sweni is believed to endure. It is not destroyed, it merely transforms, perhaps becoming encoded in the very structure of space-time, or perhaps escaping in the elusive wisp of Hawking radiation. This principle brings a profound sense of continuity, a quiet reassurance that every moment, every memory, every tiny piece of your being leaves an indelible mark. Like an ancient story etched into the stone of time, the universe holds on to its narratives, preserving them across epochs. It's a comforting thought, isn't it? That even as things change and fade, their essence, their informational blueprint persists. The universe, in its quiet wisdom, remembers. It keeps a meticulous, silent record of everything that has ever been, an infinite scroll of cosmic events, waiting to be read by the patient eye of discovery. There is a subtle beauty in this preservation, a timeless ballet of data being rearranged, never truly disappearing, always re-emerging in new forms. This intricate dance of information leads us to imagine the universe as a kind of vast, living computer. Not a machine with wires and circuits, but a grand organic system, where every interaction, every particle's journey, every gravitational embrace is a form of computation. The laws of physics, then, become the programming language, elegant and precise, guiding the cosmic symphony. From the gentle swirl of a galaxy to the quantum dance of subatomic particles, every event is a calculation, a step in an unimaginably vast and complex program. It is a universe that breathes algorithms, where its very existence is a continuous, unfolding computation. This perspective suggests a universe that is fundamentally logical, yet infinitely creative, endlessly processing and generating new forms, new structures, new stories. It is a universe that is always working, always thinking in its own profound, silent way, creating the intricate tapestry of reality one delicate calculation at a time. And as you rest, imagine yourself a tiny, beautiful pixel in this grand cosmic display, an essential piece of the universe's magnificent, living code. Your very presence adds to its richness, your quiet contemplation a gentle whisper in its immense computation. So, let your thoughts about information, about the universe as a silent, remembering entity, softly guide you now. Allow the idea of reality as a grand projection of everything being eternally preserved to soothe your mind. There is a deep peace in this understanding, a sense that even in our quietest moments, we are part of an unimaginably vast and intelligent design, a cosmic code that hums with life and meaning. Asterisk, asterisk, asterisk. Now, let us drift into realms where matter itself takes on astonishing forms, where the familiar rules seem to gently bend and twist. Tonight, we explore the exotic matter of the universe, those mysterious, rare, and often theoretical substances that challenge our deepest understanding of what is real. Close your eyes and imagine a universe brimming with possibilities, where the ordinary is merely one facet of an infinite jewel. First, let us softly touch upon antimatter, the elegant, elusive twin of everything we know. For every particle of matter, there exists a corresponding antiparticle, identical in mass but opposite in charge and other quantum properties. Imagine, if you will, an anti-electron, a positron drifting like a ghostly mirror image of an electron. When matter and antimatter meet, they don't simply repel. They vanish in a silent, beautiful flash of pure energy, a perfect annihilation that leaves nothing but light. It is a cosmic dance of disappearance and transformation. In the early moments of the universe, there was believed to be nearly equal amounts of matter and antimatter. But for reasons we still gently ponder, a tiny imbalance allowed matter to prevail, creating the universe we know. Yet antimatter is still born in high-energy cosmic events, in the hearts of dying stars, and even in fleeting moments within our own atmosphere. It's a whisper of what might have been, a reflection of our world that exists only briefly, like a fragile dream. When you consider your own body, every atom, every cell, imagine its silent antimatter counterpart existing, perhaps in a distant corner of the cosmos, waiting for a rendezvous that could only end in a brilliant, energetic farewell. It reminds us that reality is balanced on the edge of a delicate symmetry, a gentle interplay of opposites that creates the very stuff of stars and silence. Then, we venture into the more speculative yet equally captivating realm of strange matter. This is not just theoretical, it is a hypothetical state of matter where quarks stun the fundamental building blocks of protons and neutrons sooty exist freely, unbound, in a dense, stable form. Imagine a tiny droplet of this strange quark matter, infinitely denser than anything on Earth, composed not of the familiar up and down quarks, but also of a heavier, more exotic strange quark. Some theories suggest that the cores of neutron stars, those incredibly dense remnants of collapsed suns, might actually contain strange matter. It is a substance so compact, so fundamental, that it challenges the very definition of what matter can be. Picture it, a silent, solid core, holding unimaginable weight in an incredibly small space. A cosmic anomaly that bends the rules of atomic structure. If it exists, strange matter would be a profound testament to the universe's ability to create forms beyond our everyday comprehension, a silent, weighty secret hidden in the hearts of dead stars. It's a kind of celestial concrete, incredibly strong and dense, a foundation for cosmic curiosities. And then, perhaps the most mind-bending of all, is the concept of negative mass. Imagine a substance that, instead of being pulled by gravity, would actually short or repel. Instead of falling towards a larger object, it would push away. If you had a piece of negative mass and pushed it, it wouldn't accelerate in the direction of your push. It would accelerate 2 feet towards you, moving in the opposite direction. This sounds like something from a wondrous dream, a physics-defying fantasy, and indeed no such substance has ever been observed. But its theoretical existence opens up incredible possibilities, from propulsion systems that could defy our current understanding of space travel, to even the creation of exotic phenomena like stable wormholes. Think of it as an anti-gravitational force, a gentle push against the cosmic pull that normally binds everything together. It is a whisper of a universe where up might sometimes be down, where objects could move away from forces rather than towards them. It is the ultimate counterpoint to all our experiences, a beautiful, impossible thought experiment that expands the very boundaries of what we can imagine. These exotic forms of matter, Thor, antimatter, strange matter, negative mass Dorothy, paint a picture of a universe far richer and more diverse than our immediate senses can grasp. They remind us that our understanding is but a tiny glimmer, and that countless forms of existence, unimaginable to us now, might be drifting through the cosmic currents. As you feel your body growing heavy and light, imagine these strange, beautiful possibilities swirling gently in the dark expanse around you, each a silent testament to the universe's infinite creativity. Let these thoughts carry you deeper into a soft, dream-filled night where all things are possible. Asterisk, asterisk, asterisk. Now, let us turn our gaze to the most profound of all cosmic questions, the very origin of everything. We've journeyed through galaxies and particles, matter and energy, but where did it all begin? Tonight, we gently ponder the mysteries of cosmic origins, the moment when existence itself bloomed from the quietest silence. Let your mind become a calm pool reflecting the deep, unknowable beginnings. We confront the concept of the universe from nothing. This isn't just about something appearing out of literal emptiness. It is a scientific and philosophical journey into how the very laws of physics, the fundamental particles, and even space and time themselves could have emerged. It suggests that perhaps nothing isn't truly empty, but a state rich with potential, a quantum foam buzzing with possibilities, from which our universe could spontaneously bubble forth. Imagine the most serene, empty canvas you can conceive. Yet within that emptiness, the latent energy, the quiet potential for an entire cosmos to unfold. It speaks to a universe that is self-generating, a cosmic seed containing all the blueprints for its own magnificent growth. It's a concept that asks us to redefine nothing, not as absence, but as a fertile ground for creation, a silent cosmic womb. This initial spark, this quiet blossoming, hints at a universe so profoundly self-contained that its very existence is an elegant, internal consistency, a perfect self-fulfilling prophecy of being. This journey back in time leads us to the Planck epoch, an era so ancient, so utterly beyond our current comprehension, that it remains shrouded in a veil of profound mystery. This was the very first whisper of time, the briefest fraction of a second after the Big Bang, when the universe was unimaginably hot and dense, smaller than a single atom, and all 4 fundamental forces, thin gravity, electromagnetism, and the strong and weak nuclear forces, thin d, were unified as one, Imagine a universe so compressed, so intense, that space, time, and matter lose their distinct identities, swirling in a chaotic, unified soup. Our current physics breaks down here. Our equations falter. It is a cosmic infancy, a moment of profound, indescribable singularity, a point of absolute beginning before anything we recognize took shape. The Planck epoch is the ultimate frontier of our understanding, a doorway to the deepest secrets of reality, an ancient cosmic dream from which our waking universe emerged. It's a moment of pure potential, a single glowing point from which all the vastness we now behold gently unfurled. And within this profound moment of genesis lies the enigma of the universe's initial conditions. Why did the universe begin with precisely the values, the constants, the parameters that allowed stars, galaxies, and eventually life to form? It is like finding a perfectly tuned instrument, capable of playing the most complex symphony, and wondering how its strings came to be set at precisely the right tension, its keys aligned with such perfect harmony. The expansion rate, the strength of the fundamental forces, the initial distribution of energy found, these values seem delicately balanced, almost uncannily fine, tuned for the emergence of complexity. Were these conditions simply arbitrary, a cosmic roll of the dice, or do they hint at a deeper, underlying principle, a quiet elegance woven into the very fabric of existence? This fine-tuning problem, this sense of cosmic precision, invites a profound sense of wonder, a quiet contemplation of purpose. It's as if the universe in its very first breath held within it the silent, perfect blueprint for everything that would ever be, a cosmic melody already composed, waiting to be played across billions of years. As you rest now, let these deep questions about creation, about a universe's earliest, most mysterious moments, gently resonate within you. Feel the vastness of time stretching back beyond comprehension, to a point of pure potential. There is a deep peace in realizing that the ultimate beginning is still a beautiful, unknowable secret, a quiet invitation for your mind to wander and wonder. Allow the mystery of origin to lull you into the deepest, most tranquil sleep, cradled by the very birth of time. We journey now from the grand, sweeping vistas of the cosmos, from the slow turning spirals of galaxies to the infinitesimally small, the hidden realms within realms. For even in the quiet heart of matter, where light barely touches, there are deep currents and profound mysteries that whisper of an order far more intricate than we can often grasp. Here, the universe continues its gentle dance, even at its most fundamental scales. Consider the quark. These are the tiny, fundamental building blocks, the very threads from which protons and neutrons are woven. They carry the very essence of matter, like the subtle melodies hidden within a symphony. But quarks are never found alone. They are bound together, held in a perpetual embrace by an incredibly strong force, a force so potent that it seems to whisper, "You shall not pass." This is the enigma of quark confinement. Imagine trying to pull two tiny, invisible magnets apart, only to find the force holding them together grows stronger with distance, as if the very fabric of space-time itself refuses to let them be solitary. They are forever cradled in their groupings and never to be observed in isolation. It is a universe where even the smallest components prefer community, a silent testament to the interconnectedness of all things, a quiet secret held deep within every atom. And as you imagine these tiny, invisible bonds holding the very structure of your world together, let your own grip on worries loosen, allowing you to drift into that same gentle confinement of rest. Then there are neutrinos, the ghost particles. They are almost massless, carrying no electrical charge, and interact so rarely with other matter that billions of them pass through your body every second, completely unnoticed, like silent, ethereal travelers on an endless journey. They are born in the fiery hearts of stars, in supernovae, and even in the quiet decay of radioactive elements right here on Earth. But what truly challenges our understanding of these phantoms is their ability to change identity. Imagine a tiny silent traveler leaving its home as a muon neutrino, embarking on a long journey across the cosmos, and arriving at its destination having quietly transformed into an electron neutrino or a tau neutrino. This is neutrino oscillation. It means these particles are not fixed in their state but are constantly shifting, like soft fluid whispers in the quantum breeze. This gentle, constant transformation hints at a deeper, more nuanced reality, suggesting that even the most fleeting elements of existence hold profound secrets about the very nature of mass and flavor. It is a reminder that even the most constant things we perceive might, in their truest essence, be in a state of beautiful, perpetual change. Let the thought of these endlessly shifting particles calm your mind, as their gentle oscillations mirror the slow, steady rhythm of your own breath. And in our quiet quest to understand these microscopic truths, humanity has built incredible cathedrals of science, giant particle colliders, buried deep beneath the Earth, accelerate fundamental particles to nearly the speed of light, guiding them along vast, curving tunnels before smashing them together. These are not violent collisions, but rather delicate dances of creation and annihilation, glimpses into a universe that was younger, wilder, and still learning to become what it is. In these fleeting moments, new particles are born, revealing themselves in the debris like tiny, luminous echoes from the very first moments of time. It is here that we search for clues to extra dimensions, for the elusive nature of dark matter, or for yet undiscovered forces that weave the tapestry of reality. Every collision is a whispered question to the universe, and every fleeting trace a quiet answer, slowly revealing the hidden architecture of existence. The search is a patient one, a gentle coaxing of nature's deepest secrets, a long, thoughtful journey into the heart of everything. And as the echoes of these tiny, immense discoveries fade, let your thoughts drift, allowing the quiet order of the micro-universe to gently guide you into slumber. As we have drifted through the vastness and the minuteness of the cosmos, a deeper, more profound question often arises, gently echoing in the quiet chambers of our minds. What truly is real? Is the vibrant tapestry of stars, the silent dance of particles, the very sensation of your breath, as solid and unyielding as it appears? Or is reality itself a concept more fluid, more subtle than we dare to imagine? Let us gently explore these whispers, not to stir anxiety, but to open the mind to the vast, serene possibilities of existence. One of the most captivating of these possibilities is the simulation hypothesis. Imagine for a moment that our entire universe, with all its galaxies, its history, its life, and your very consciousness, is not fundamental in the way we perceive it. Instead, it is a grand, exquisitely detailed simulation, running on a colossal computer far beyond our comprehension, created by an advanced civilization. Think of the intricate worlds built within our own digital realms, with their simulated physics, their emergent complexities. Now, stretch that thought to an unimaginable scale. If such civilizations are possible, and if they reach a certain level of technological prowess, would they not almost inevitably run ancestor simulations? Simulations so realistic that the beings within them would have no idea they were part of a larger program. This isn't a jarring thought, but a soft poetic consideration. It gently asks us to look at the elegant patterns of physics, the mathematical precision of the cosmos, and wonder if these aren't the beautiful underlying codes of a grand design. It suggests that our universe, in its deep order and predictable laws, might be less of a random occurrence and more of a sculpted experience. And in this thought, there is a certain peace. For if we are part of a beautiful simulation, then perhaps our struggles and triumphs are part of a grand narrative, cared for and observed in a way we cannot yet fathom. Let the notion of your world as a meticulously crafted tapestry, woven with unseen threads, bring a gentle calm to your spirit as you drift towards the quiet depths of sleep. And if a simulation is possible, then perhaps the very idea of the universe as an illusion is not so far-fetched. This isn't to say that what you see and feel is fake in a deceptive way, but rather that its realness might be fundamentally different from what our senses report. Think of a dream so vivid and compelling that within its embrace, it feels utterly real. Only upon waking do we understand its illusory nature. Yet it held profound meaning. Perhaps the universe operates on similar principles, where our perception is a powerful lens, shaping the raw data of existence into the familiar world we inhabit. Ancient philosophies have long whispered of the world as Maya, an intricate dance of illusion, a veil woven over a deeper, more fundamental truth. Modern physics, too, with concepts like quantum entanglement and the observer effect, hints that consciousness plays a more active role in shaping reality than we once believed. It suggests that the solidness of things might emerge through observation, like a gentle fog coalescing into form when we turn our gaze upon it. This perspective invites a profound release, a letting go of rigid definitions of what is real and what is not. It suggests that beneath the surface of apparent reality lies a fluid, ever-changing essence, allowing for a deep sense of peace in the acceptance of its ephemeral nature. As you consider the possibility of the universe as a magnificent, unfolding dream, let your mind relax into its beautiful, gentle mystery. These questions, these soft probings into the fabric of what we call existence, reside at the beautiful, often quiet, intersection of philosophy and physics. Science seeks to describe the mechanisms of the universe, to measure its particles, chart its forces, and map its vastness. Philosophy, on the other hand, gently asks the deeper questions. Why is there something rather than nothing? What is the nature of being? What does it mean to know? When these two paths converge, they do not create a collision, but a gentle fusion, enriching our understanding in ways neither could achieve alone. Physics gives us the tools to explore the universe's mechanics, and philosophy gives us the framework to contemplate its meaning, its purpose, its ultimate reality. It is in this contemplative space, this quiet pondering of the deepest questions, that our minds can find a unique form of rest. We are not expected to find definitive answers, but rather to embrace the gentle wonder of the questions themselves, to allow the profound mysteries to soothe our restless thoughts. And as you rest in this space, where the measurable meets the immeasurable, where facts meet profound ideas, let your mind soften, allowing the weight of these vast thoughts to gently carry you into a peaceful slumber, knowing that the journey of understanding is a gentle, endless one. Even as we have journeyed through these quiet truths, acknowledging the profound mysteries that still enshroud our understanding, humanity's gentle gaze outward continues, unwavering and full of quiet determination. The universe, in its vastness, forever invites our curiosity, beckoning us to explore, to question, and to reach a little further into the dark. This is a journey of quiet courage, a testament to the enduring human spirit that seeks its place within the cosmic dance. Our pursuit of understanding is beautifully embodied in the next generation telescopes and observation technologies that are slowly unfurling across our planet and into the silent void of space. Imagine enormous, intricately designed mirrors, like vast, patient eyes, gathering the faint, ancient light from the farthest reaches of time. The James Webb Space Telescope, now gracefully orbiting beyond Earth, gazes back to the universe's infancy, capturing the first fragile glows of newborn galaxies, seeing through veils of cosmic dust to reveal hidden stellar nurseries. And on Earth, arrays like the Square Kilometer Array, when completed, will listen to the universe's quiet radio whispers with unprecedented sensitivity, unraveling the mysteries of dark ages, probing the origins of galaxies, and perhaps even detecting the faint technological murmurs of distant civilizations. These instruments are not just machines, they are extensions of our collective dreaming, gentle probes into the unknown, allowing us to witness the universe unfold, to trace the slow ballet of its evolution. Each captured photon, each faint radio wave, is a soft message from the past, guiding our understanding forward, deepening our appreciation for the gentle, persistent unfolding of cosmic history. Let the thought of these vast, silent observatories, patiently listening to the universe's ancient songs, bring a deep quiet to your own thoughts as you prepare to rest. Beyond observation, our spirit of exploration reaches out, literally into the cosmos through ambitious future space exploration missions. Imagine probes designed to delicately touch the icy moons of Jupiter and Saturn, like Europa and Enceladus, searching for the hidden oceans beneath their frozen shells, where the gentle stirrings of alien life might thrive, warmed by unseen forces. Consider the persistent hum of rovers on Mars, patiently sifting through ancient dust, seeking whispers of past water, past life, painting a clearer picture of our planetary neighborhood's deep history. And perhaps one day, the gentle arc of human voyagers will extend beyond our moon, venturing toward Mars, a quiet testament to our species' innate drive to know, to see, to touch. These missions are more than technological feats. They are expressions of a deep yearning, a quiet longing to understand our place in the cosmic story, to find echoes of life, or simply to marvel at the silent, majestic beauty of other worlds. They remind us that the universe is not just something to be observed, but something to be engaged with, to be experienced, with a gentle, adventurous spirit. Allow these dreams of future journeys, these quiet expeditions into the unknown, to guide your own spirit into a tranquil, explorative dreamscape. And in this endless quest, we continuously redefine humanity's place and significance in the cosmos. We are small, yes, within the vast, silent expanse, mere specks on a pale blue dot. but our consciousness, our capacity for wonder, our ability to ask these profound questions and build these magnificent instruments elevates our being. We are the universe observing itself, the cosmos awakening to its own beauty and complexity. The iron in your blood, forged in ancient stars, the oxygen you breathe, sculpted in distant supernovae, the atoms of your body, tracing their lineage to the earliest, most primordial moments. These are not just scientific facts. They are poetic truths, gentle reminders that you are intimately connected to everything, woven from the same stardust that forms galaxies and nebulae. You are not separate from the universe. You are a quiet, conscious part of its unfolding story, a small warmth within the grand, dark cosmic sea. This realization, this gentle understanding of your profound belonging, can bring a deep, abiding peace. The journey of discovery is an endless one, filled with an infinity of questions and the promise of perpetual new discoveries. For every answer we find, a dozen new questions gently bloom, inviting us deeper into the garden of cosmic truth. The universe does not reveal all its secrets at once. It whispers them, slowly, patiently, through the language of starlight and the murmur of quantum fields. And this is a beautiful thing, for it means the wonder will never cease. The quiet invitations to explore will always be there. So, as you drift into sleep, carry with you this gentle sense of belonging, this quiet awe for a universe that is both endlessly mysterious and profoundly welcoming. We've drifted through 100 quiet truths, from the warp of the galaxy's disk to the farthest halo stars, from newborn suns to long-dead remnants, from dust and gas to light and shadow and everything in between. The iron in your blood was forged in stars. The oxygen you breathe was sculpted in ancient explosion. The atoms of your body trace their lineage to the earliest times, and you are floating within it. A small warmth in the dark resting in the spiral arm of a quiet, radiant sea. I hope you sleep well and dream softly. Good night.